So, good morning, everyone. Welcome to today's my demonstration. Uh, my name is Surya, and in this presentation, we will explore one of the most essential topics in backend development, which is nothing but Spring Boot and RESTful API design principles. Okay, and RESTful API design. So, as you guys are already aware, sorry, so most of the guys may already aware about the REST APIs. It's nothing but REST APIs are the uh, foundation of how modern applications communicate from mobile apps to microservices, and Spring Boot makes building these APIs fast, efficient, and scalable. So, REST APIs are the foundation of how modern applications communicate from mobile app to microservices. So, and also Spring Boot makes building these APIs fast, efficient, and scalable. So REST API is that is a concept which is used for communicating from mobile apps to microservices. Microservices is nothing but many services. Each services have separate process ID, and of it running it each of it running independently, and it has a separate memories. So today we'll cover both the theory behind the RESTful design principles, and then move into a hands-on demo where I will show some how to build a simple REST API in Spring Boot. Okay, so what is REST? REST stands for representational state transfer. REST stands for representational state transfer. Okay, so REST stands for representational state transfer. It is an architectural style for building APIs. It is an architectural style for it is an architectural style for building APIs. API is nothing but application programming interfaces that use HTTP that use HTTP to perform GRET operations on data. So, RESTful APIs are it is like a stateless. Stateless means each request is independent. It is not dependent on each other, and it is uniform. It means use consistent URIs and conventions, and is cacheable. These responses can be cached, and it client server separated. So I will show you example of stateless, uniform, cacheable, and client server the uh, upcoming session. So examples of REST APIs include login services, product catalogs, booking systems. They are everywhere in modern development. Okay, so next thing that I'm going to discuss is key REST design principles. This is very important, guys. REST design principles. So let's look at some RESTful design best practices. It uses nouns, not verbs in URIs. You mean use first point is nouns, not verbs in URIs. Say for example, thus is the correct one. Instead of get users. So users, this is the correct one. Users instead of get users. Okay. Next one is use plural resource names. It means orders, example, orders, products. Use plural resource names. Okay. Orders, products, employees, students. So that one design principle is maintain resource hierarchy. Um, Example, um, users not want orders. So this is the rest of design principles. It keep your eyes simple and initiative. So next is let's look into the HTTP methods, RESTful API, HTTP methods, and status codes. So REST heavily relies on the HTTP methods. Repeating, REST heavily relies on HTTP methods to define its actions. Very important theoretical of it. So it will be this theoretical concept will be very helpful when we attend the interview. So REST heavily relies on HTTP methods to define actions. So for example, get get method is used to retrieve data. Second one is post. This is to create new data. That one is put. This is used to update full resource. Post means create new data. Get means retrieve data. Put means update full resource. Fourth one is patch. It is partial update. And one is delete. It means remove resource. Patch means partial update. And it's equally important to return the correct status code. It's equally important to return the status codes. Let me tell you codes which I have around its meaning. First one is 200. It means okay. Second one is 201. It means creator. That one is 400. It means not found. One is 500. Means general server error. Okay. So this helps consumers of the API understand the results of their request clearly. This helps consumers of the API understand the of their result of their request clearly. Okay. Next, let's see some REST URI design examples. Okay. A few examples of well-structured URIs that I'm going to show you. So first one is users. It means list all users. Second one is users 101. It means get user with ID 101. That one is users not one orders. It means all orders of user 101. Fourth one is products 5 use means use of product 5. So don't include actions in URIs like don't include actions like URIs like create user or delete order instead of it. Let the FTP method define the auction. Method itself can define the auction. These are not mentioned in the URIs. Okay. So next thing is response structure and error handling. Yeah, about the response structure and error handling. From REST responses should be consistent, informative, or JSON formatted. So in JSON formatted, it is in the most modern um, success response will be look like. This is what the success responses will be look like. Yeah, error response will be like the status line is instead of success, you will see like error in the message. There will be a message like users not found on the code 404. 404 is not found error. Next one is 400 means add request 404 not found. Okay. So next thing is sort. Let's look into the sort Spring Boot demo. Um, let's look into any we have a controller class. So let's look into this validations control program controller program. So in this program, so, the key functionalities of this controller is to expose the uh, this B1 validation rules, reload endpoint via a post method. The post B1 validation rules slash reload. Uh, so this endpoint is triggered when we want to reload the validation rules from the database or from another system into memory or cache. This endpoint is triggered when we want to reload the validation rules from the database or from another system into memory or cache. So it receives a post request. This is a post request, and um, it calls a reload validation rules and params method. This one, it calls this method, and after that, it responds with a message confirming that reload is successful. This is useful in real-world application where validation rules change dynamically, and we need to refresh the in-memory rules without restarting the applications. So let's look into the dependency injection and clear code. So in the constructor of this controller, you can see that uh, it takes uh, the construction of this controller. You can see that it takes an takes in a dependency called validation rules service, and yeah, so this is an interface that contains the business logic, and it follows constructor-based dependency injection, a recommended best practice in Spring Boot. The separation of concerns helps us keep the controller clean and focused only on handling HTTP records, while the service handles the actual business logic. So next, let me tell you the real world example scenario. So imagine you are working on a financial application that validates transactions like UPI payments, bank transfers, or credit card checks. So these validations may change frequently. For example, if a new rule is added to block transactions over a certain limit, instead of restarting the application each time a rule is added or changed, we just call this endpoint post slash v1 slash validation rules and slash reloaded. So this triggers the reload of the latest validation logic into cache, keeping the app fresh, dynamic, and resilient. Okay. So next, REST response and status code. So the method returns a HTTP status code 200. Okay, status using responsibility. So this is the clean and standard way of sending responses uh, um, in REST APIs. So if needed, this could be expanded to return JSON with timestamps. And so to summarize, this is controller provides a production-friendly way to dynamically refresh validation rules. It follows a Spring Boot best practices like a trust controller, clean routing, and service injection. So this kind of functionality is widely used in real-world microservices or architectures to support flexibility and high availability. So next, let's look into about the core production readiness topics that are essential for any real-world Spring Boot um, application. So it includes AWS easy to set up, Spring and Maven profiles, advanced Spring security, HMAC, SHA-256, and tips for present. Uh, so each concept we discussed today is widely used in real-world systems, from enterprise banking platforms to the e-commerce and microservice-based systems. So first, let's look into the AWS easy build and Spring Boot deployment. So the theoretical, let's look into the theoretical concept. So let me tell you the what is EC2 instances. It is a virtual Linux or a Windows machine hosted on AWS that we can host our services. So EC2 stands for Elastic Compute Cloud is a virtual Linux or Windows machine. Yes, it lets deploy, bring boot jar, jar files as standalone web servers. Okay, um, let me tell you the real world workflow. So first we'll create an EC2 instances. Will be uh, with Linux. So when we create EC2 instance, we'll be providing which type of operating system, what is the storage we want, what is the RAM size we want, what is the processor we want. So once you have created the EC2 instances, we can access the machine, and then once we access it, in that we will be installing the Java. This is the command which we install. Open JDK. So after that, we'll be copy our Spring Boot jar using a SCP. Like so, after that, we will run the app. Okay, this is the command we will use: Java hyphen jar app name dot jar. This is the command to run the app. So the use case in the real world, like a fintech startup deploys their payment processing service on EC2 for easy scaling. So no need for a Tomcat setup. Just run the dot jar directly. It will be automatically 24 per 7 and 365 days available to the customers or users. So next topic is Spring Boot profiles and configuration. So before which I hope you understand about the uh, AWS easy to instance for you to create a machine that will be hosting our services. It will be running always. Okay. So next thing is Spring profiles. So Spring profiles are nothing but it allow you to uh, run your app with different configurations for if you want to uh, run it on dev environment, so you'll have dev environment, and you'll have test environment, and you'll have prod environments. Okay, so you define application hyphen dev dot YAML and application hyphen prod dot YAML, etc. Okay, so in real world use case, in dev environment you use an in-memory host database. Web environment you use an in-memory host database. In the real world use case, in prod it use MySQL database based on the active profile. Spring loads us right configurations like There will be separate server port number and DB URL. Okay. So next, let's look into the Maven profiles. Maven profiles, it control build time, behavior. So Maven profiles, it control build time, behavior, and different builds for dev, test, and prod. Okay. So it helps to include or exclude dependencies, properties, sources. Okay. So so this was about the Maven profile.